Hey, everybody. So we're going to be looking at 15.2 part 1 today, looking at what are called inscribed quadrilaterals. Just first thing to point out, my pen has been kind of glitching out when I make these videos. So if it starts to look really messy, I apologize, but I haven't been able to fix the issue. So just bear with me if you can. Okay, but yeah, take a minute, go ahead and just pause the video, copy this slide, and then we'll get into it. Okay, so yeah, inscribed quadrilateral theorem. Here's what it says. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. All right, first thing, just remember, what does it mean for a polygon to be inscribed? It means all of its vertices touch the edge of the circle. All right, so that's why this is considered an inscribed quadrilateral. You know, it has four sides. That's why it's a quadrilateral. Okay, but yeah, here's the rule: opposite angles supplementary, add to 180. All right, so on your notes, if you want to kind of show yourself, angle B and angle D, those would be considered opposite angles to one another. And yeah, those would add to 180. Same thing with angles A and C. Those would also be opposite and they would add to 180. Okay, one thing to not mix this up with, when we were learning about parallelograms a while back, their opposite angles weren't supplementary, they were congruent to one another. Okay, so it's different than that. It's easy to maybe get it mixed up. Okay, but these add to 180. Okay, and that's really what it's all about. One thing to realize, this quadrilateral has four inscribed angles, right? Angle A, B, C, and D, they're all inscribed angles. And we saw that on our last lesson. And those rules for inscribed angles still apply to these. If you guys remember, the big idea was that the measure of an inscribed angle and its intercepted arc are it's one half of the arc. The angle's half the arc, and the arc is double the angle. Okay, that is still a huge part of this lesson. So this is almost like a continuation of 15.1 part 2 in that regard. Okay, so yeah, let's give it a try. Go ahead and copy this, and we'll find DAB. All right, so first things first, let's highlight it. Arc DAB. That arc starts at D, goes through A, all the way around to B. Okay, here is the big thing to realize. This is the intercepted arc to this inscribed angle. If I were to highlight the side lengths of angle C right here, notice they touch the endpoints of this arc. Okay, so this is the inscribed angle. This is its intercepted arc. And yeah, we know there's a relationship between these, right? This angle is half the measure of this arc. Okay, so now my goal is, can I find this angle? Okay, well, here's the next thing I notice. This is an inscribed quadrilateral, and these opposite angles add to 180. Okay, so there it is. So you can show it in your notes and also do it in your calculator. Taking 180, subtract 74 is going to give me the other angle. And let's see, it looks like we're getting 106. Okay, so there it is. We just found this angle here. I guess I'm going to erase the arc. You don't necessarily have to. And yeah, now we know this thing's 106. Okay, now we know the measure of the inscribed angle. We can get the measure of the arc because, again, the arc is double the angle. So I'm just taking this thing, multiplying it by 2, and that is going to get me the whole arc. Looks like it's going to be 212 degrees. Okay, so there's my whole arc. Okay, and let's write it out properly. So let's say arc DAB equals 212. Okay, so you can see we're still very much using the rules from the last section. We're just kind of now adding on inscribed quadrilaterals and these opposite angles. All right, cool. So I'm gonna have you guys try one a lot like this. Actually, this is literally the same shape. Okay, so you don't need to recopy this shape. I just want you to find a different arc. Okay, so I want you guys to find arc ADC that starts at A, goes through D, all the way to C. Okay, so you can use that same shape you drew on the last example. Go ahead and see if you can find this. All right, well, here's what I noticed. A lot like the last problem, this inscribed angle is intercepting the arc that we're looking for. So yeah, the angle is half the arc. If I can find this angle, I can double it and get the arc. How do I find the angle? Well, inscribed quadrilateral. These are supplementary, right? So taking 180, subtracting 85, and it looks like we're getting, 85, looks like we're getting 95. Okay, so there's the measure of this angle. Now that I know what that is, I can use the rule from the last section that this angle is half the arc, so the arc is double the angle. Multiply it by 2, and it looks like we're going to get 190 degrees. Okay, so yeah, let's write out. Arc ADC equals 190. Okay, cool. Let's keep going. All right, this one's throwing in weirder values. Don't over, complicate it, or don't be afraid of it. Go ahead and just copy this and we'll find a couple measures together. All right, so this is asking us to find angle P and arc PSR. Okay, let's start with angle P. All right, here is that angle. All right, first thing I'm thinking is, do I have the intercepted arc? I don't have the measure of this arc, and right now I don't think there's a way of me finding it. Okay, so what else do I know about this angle? Well, I know that R is opposite it, right? And this is an inscribed quadrilateral. These are going to add to 180. Okay, and they both have y as their variable. I can make an equation out of this. Okay, so let's go ahead and write it out. I know that 5y plus 3 plus this other angle, 15y plus 17, equals 180. Okay, and then from here, we're just solving for y. We'll see what we can do with it once we get it, but this is the math we can do. So we got some like terms. 5y and a 15y gives me a 20y. 3 and 17 gives me 20 equals 180. Okay, and I'm just going to do this in my calculator real quick. I know I'm taking 180, subtracting 20. So that gives me a 20y equals 160. And then dividing by 20, looks like y equals 8. Okay, they didn't ask for us to find y, but now that we know it, we can plug it back in and get angle P. We know that y is 8, so we can plug 8 back in right there, and we'll have the measure of the angle. Okay, and you can just do this in your calculator, but I'm going to write it out. So we're doing 5 times 8 plus 3. Okay, looks like that's going to give me a 43, right? Okay, so there it is. This is a 43-degree angle. Okay, and let's write it out. So angle P equals 43 degrees. Okay, cool. So let's see what they want after this. They want the measure of arc PSR. Let me highlight it. That starts at P, goes all the way through S, all the way around to R. That's the arc they want us to find. All right, here's the theme of all of the last couple sections. The arc and its inscribed angle, right? I can see that Q, its side lengths, touch the endpoints of this arc. The measure of angle Q is half the measure of this arc, okay? Or the arc is double the angle, okay? And look at, I can find the measure of angle Q. I know what y is, all right? You don't need to do all these arrows, but I can plug y into this, and I can get the measure of this angle really quick. Okay, so I'm going to do 8 squared plus 53. So let's see. Looks like real quick, I'm getting, it's 117. Okay, now that I know the measure of the angle, I can get the measure of the arc by doubling it. So 117 times 2, looks like I'm getting 234 degrees. Okay, so there is that. So let's write that out. So arc PSR equals 234. Okay, so not as difficult as it might have seemed. It's just, we had to solve for y. We figured out our equation, and then from there we're just plugging stuff in and using the rules that we've learned before. Okay. All right, I'm gonna have you guys try one last problem here. So they're asking you to find angle W and an arc TWV. This is a lot like the last problem. Okay, so to kind of get you guys going on this after you draw it, angle W is down here. Obviously, to find the measure of that angle, we need to figure out what Z equals. We'll plug Z back in. Okay, so to find out what z equals, we need to realize there's a relationship between these opposite angles of this inscribed quadrilateral. Okay, these opposite angles, they're gonna make an equation. I'm being vague on purpose. Okay, so go ahead and make that equation, see if you can solve for z, and then plug it back in and find w. Okay, you can start with w right now. Okay, so I was being vague before, but hopefully you realized these opposite angles are supplementary. They add to 180. Okay, so I'm going to start with this one off the top. So I know that 12z minus 27 plus 37 plus 5z equals 180. Okay, got some like terms. 12z and 5z gives me a 17z. 37 minus 27 gives me positive 10. Be careful with that. Equals 180. And then I'm grabbing my calculator. 180 minus 10. Looks like I'm getting 17z equals 170. Divide by 17. Z equals 10. I'm really hoping this algebra is not what is tripping you up. But if you still struggle with that, talk to me. Okay, cool. So now that we know z, we can plug it back in to right there. Okay, so I'm just going to do it off to the side. So 37 plus 5 times 10. Okay, so let's see. Looks like we're getting 87. So there it is. 87 degrees. Okay, and let's just write that out. Angle W equals 87. All right. If you haven't yet, go ahead and pause the video and now try to find arc TWV. Okay, just to highlight it. Starts at T, goes through W, all the way around to V. Okay, this is the intercepted arc for this inscribed angle. Okay, and we know what Z equals now. See if you can make some sense out of that. Plug it in and see if you can find the measure of that arc. Okay, so yeah, again, we know that Z is 10. So doing this math, 12 times 10 minus 27. See what happens? Okay, I'm getting 93. 93, which by the way, I could maybe have just done that by looking at this opposite angle. These should add to 180. If this is 87, this had to be 93 for them to add to 180. Okay, but either way, I got it. Now I know this inscribed angle is half the measure of this intercepted arc, just so we're all on the same page. Notice how its side lengths touch the endpoints of this arc. Okay, so this angle is half the arc. The arc is double the angle. Okay, so I'm taking 93 times 2. Looks like 186. Okay, so this is getting kind of messy. I'm going to put it over here. Okay, but there it is. Okay, so I'm going to write my other answer. TWV, arc TWV, 186. Okay, so again, I'm sorry if this was a really like messy looking video, like with my cursor like messing up. I've noticed that's been happening recently. I'm going to try to fix it. We'll see. But yeah, there it is. So yeah, there's going to be an assignment looking at this. So give it a try and see how you do. Yeah.